Hello and welcome to this new Java Lab tutorial. My name is Abdelkader Matan. I'm a senior software developer. I have 14 years of experience in building Java application, and in this video I want to share with you how to implement the singleton pattern in Java in a proper way. So let's start. So I have this class which I called my singleton. Normally the common way of implementing a singleton pattern in Java is to define a class and to inside this class to have a variable, a static variable, which is of type of the class itself. You can call it whatever you want, and to make the constructor private, and to have inside this class a static method which will check if an instance of this object is already there. If it's null, if the instance of the object is null, then it will create it and return it back. Otherwise, it will return only the existing instance. And like this, you have a single instance of these objects of this class. Okay, I have this class, as I told, then I have a trade class, where I will specify the name of the trade. The class is extending the trade class of Java. It has its own name. I will set the name of the trade only for debugging purpose, and I'm using the countdown latch in order to be able to start the. I will instantiate two threads, and I want to start the two threads simultaneously at the same time. In order to do that, in the run method, I will call the latch await, which will cause that the thread will wait till the countdown of the latch is equal to 0. So in this thread, I am acquiring an instance of my singleton, calling the get instance method, which I've defined here in this in my singleton. And I am printing some information: the trade name, and the singleton instance. I want to demonstrate. If I have only one instance of this class, even if I am calling the get instance from two different states, which I will do in the main class. So here in the main class, I have a static countdown latch variable, and I have a method where I will create two objects of my trade 1 and trade 2, passing the name as trade 1 and trade 2, and passing the latch as a parameter in order to cause the trade, as I say, to wait. And I will start both threads and count the down latch and decrement the latch. And that means once the latch, since we pass the argument here to 1, it will decrement one time, and once the latch reaching the value 0, then both threads will be released. The both threads will be released and will start simultaneously. So that's it. I have my singleton. This is the common way, as I told, to implement the singleton, static singleton. But we will see another way, because I will tell you why this is not the overall proper way to implement it. But let's start this demo right now. Let's start the demo. As you can see here, trade 2 singleton instance, and if you see this ID here, ID is the same as by trade 1. But as I told, this is not the proper way to define a singleton, because it can happen that two threads reach this point here where we are checking if the instance is equal to null, and this check can evaluate in a multi-threaded system, a multi-threaded scenario, can evaluate to true. Then we will end up with different instances. Let's demonstrate this. Let's cause the thread to slip 1 millisecond. So let's throw the exception here. So let's start the demo again. That means each thread will, once it's reached this point, it will slip 1 millisecond. Yeah. And as you can see here, now I have two different IDs. That means two different instances for my singleton, and that's what we want to do. That means we have broken the pattern of being singleton. In fact, that we want to have only one instance. That is the main idea behind the singleton pattern. We want to have only one instance of this class, of this object. In order to solve this, we have now to add synchronized modifier. That means the first thread which will reach this method will block the other threads until he is done with his work, and afterwards another thread can go inside the method and acquire the instance. That means the thread, once it's reached the method, he will acquire a lock on this block, and he will acquire the create singleton and return it back. Now let's demonstrate. With synchronized, we should get not different IDs, but the same ID. And as you can see here, we have now the same ID for both threads. But with this implementation affects the performance, because each thread which will try to call this method, he will acquire a lock on this block, and all other threads have to wait. In order to solve this, we have to implement so-called double check locking pattern. That means let's define this method here, and let's comment the other one. What we will do in this method, first we will not synchronize the whole method, but we will acquire a lock only if the instance is null. Means if the instance doesn't exist, then the thread will acquire the lock on this block using the synchronized, and we will check again. That's why double check, because he will acquire. It can happen again that inside this block two threads simultaneously execute this line of code, where we are trying to instantiate the singleton, and we will end up again with two different instances. That means we have two different things here. First, we will not synchronize the whole method, but we will synchronize this much of code where we are trying to instantiate the singleton. And on top of that, we synchronize only if the instance is null. That means the first thread which we will run here, it will check, okay, the instance is null, then we will end up with this thread in this block, and we will create the instance and give it back. But the second thread, he will another thread which will reach this block of the method. He will check the instance is not null, then he will just go here and return it back. Okay, let's demonstrate this. And as you can see, we have only one instance with the same ID, and now the threads have not to wait of the lock. Have only to wait to the lock to get the lock if the instance is not null. So let's summarize what we have done. I have my singleton class. We have demonstrated what is the common way of creating a singleton, and the common way is to define a static variable which has the same type as the class itself, and to make the constructor private, and to define a static method which will check if an instance of this class is already there and give it back. Otherwise, it will create the instance and give it back. And as I told, this is not the proper way of doing this. That's why we have added the synchronized modifier in order to make the whole block of this method synchronized, and in order not to end up with having multiple instances of the singleton. And because this way of defining the singleton, of creating the singleton using synchronized, has some performance impacts. We have learned also how to optimize the performance using the double check locking pattern. I hope this video you learned something in this video and it was interesting for you. If it was like this, then please don't forget to smash the thumb and like the video and subscribe to the channel in order to support me providing more content on the channel, this channel. See you in a later video and have fun with this tutorial. Bye.